So I made the second prototype of the H-tube and it looks really good. And in this video I want to get you through the building process, and I want to especially focus on the differences from the previous one, because the previous attempt to make the prototype showed us several problematic places. So let's start with the anode cap. This is the main structural part inside the Nixie tube, and it holds all the other parts on the place. And to prevent movement of the parts, it must be as stiff as possible. This is a problem here because we have a large area of thin sheet metal here, so it does this. It suffers from buckling. The sheet metal buckling is quite a common problem, and to avoid this, manufacturers forms various stiffening ribs and profiles into the surface of the metal. From all the shapes that I found on the internet, this one is the best. It would allow us to align the stem support during the spot welding to the anode plate without making any special jigs for it. To get some basic idea of how the press forming of this shape can work, I designed this press forming die to be printed on a 3D printer. It's just two parts and the metal will go between them, and I will press it on a hand press that I have available in my shop. As you can see here, it will be a lot of work to get this 0S system into 5S, but anyway, for printing the parts they need to be extra strong, so I'm using Prussian PLA with 10 perimeters instead of 5, which is the normal settings, and 50 to 70% infill. This turns out quite well, it holds the pressures. The steel I'm using for the anode cap is called DC01. It's a steel, it's a deep drawing steel which is designed for drawing operations and very good for this type of forming. It has quite low tensile strength of 300 megapascals, and it should be the best what we can use for this type of forming. And this is the first result. The center part is perfect, but around it there is quite a lot of wrinkles, so we will need to find a way how to get rid of it. But what is important, already this shape prevents the metal from buckling quite a lot. And this is how it would look on the already preformed part for the anode cap. I did some more tests with different shapes of the dies and different ways how to form the sheet metal, and I quickly realized that I will need a more powerful press because this handheld one is not enough. So I bought a 20-ton hydraulic press. The press is really slow, but for prototyping it's good. Important is that it was cheap, it was like 150 euros, so for our purpose of testing it's enough. With the hydraulic press I could test another forming method. It's called rubber pad forming, and it's about pressing the rubber pad against the die, and the pressure makes the rubber flow into cavities and around the edges. In the end, I decided to return to the very first shape of the jar lid with the concentric circles, and instead of using two solid parts for the die, I will use the solid bottom. Then I will put a rubber sheet in between, and with a flat upper part I will press the rubber and it will flow into these grooves here, and it should take the metal with it and form the concentric rings into it. The result produced with the rubber pad was nice, smooth, but still the anode plate tend to bend like this, and I found that the problem is here in these cutouts. It still tends to buckle like in this direction. At the moment I will use what I have, but in the next iteration I'm going to redesign these cutouts so that we have full solid edge bend here, which will help to improve the stiffness of the overall part. To save time, I'm using oven here instead of chemical blackening. The result is not very nice, but this is far from the final result what we will use in the production tubes. In the comment section under the last video I got really great tips, and one of them was using a reamer tool to increase the diameter of the holes in the digits. I made a mistake and designed them too small, so I need to increase them before I order a new batch. And this is one of the reasons why I love YouTube so much. You get immediate response from 10 times smarter people than you are, and from people who have far more experience than you, and this really can get you farther in your project. I'm using just a couple of digits here, not a full digit stack, but for the overall test of function of the tube it will be enough. Another improvement I'm testing here is the new way of stripping the ends of the thermal wire. The manufacturer recommends to use a molten sodium hydroxide to strip the ends, submerge them into the water, and then you can clean them and spot weld easily. So let's see. The thermal wire is a nickel wire coated with layer of ceramics. And the reason why we are using it is that we want to use this layer of ceramics as an insulator against glow, because the wire will be directly connected to the digits. They will be glowing, and we want to prevent the wire from glowing, so it needs to have some layer of insulation. I think this is very good result, considering that this is very first test of stripping the thermal wire this way. And it will definitely need to improve the cleaning after the stripping, but As you can see, it's working very well. And now it's time for the most stressful part, the glass work. For this beaker here we will need higher flow of nitrogen. Last time the 0.7 liters per minute was not enough, so I'm mounting here a new rotoflow meter for 10 liters per minute, so we will see. This time I want to heat all the edge at once to softening temperature and then seal it with the graphite pedal. Last time I was heating it like step by step and it wasn't good. It developed a lot of stress and also the seal was not uniform. So this time I hope the seal will be uniform and I will avoid development of the stress and the glass will not crack. To be able to heat the overall seal I will need much more heat, so I had to mount another pair of the jets to the carriage burner. You can see we have now 4 of them, so this should help us. I still have the handheld torch and this will be a backup solution. This time the seal went out really well. It's beautiful uniform seal all around the edge. It looks like from a professional factory. And I took extra care to cool it slowly and including the front window, because the window last time cracked because of the stress development. And now finally the absolutely easiest part, welding the long exhaust pipe. This is so simple that I don't even need to change my big torch for a small one, which I normally use. I'm confident enough I can do it. My impatience, the big torch and bad access to the pipe caused that I completely screw it up. The glass welded all together, closing the exhaust channel in the pipe, and so I had to fix it. I was trying to scrape the glass and crack off the tube. This is the way how I normally do it, and then weld a new pipe. And then rushing, I made another wrong decision. When I need to open finished Nixie tube for testing, for measurements, I always do it like this. I always scrape the top and then I hit the nipple with the tungsten rod and it always cracks off and I can use it. But in this case it didn't work. It took away all the tubing, which is not such a surprise, but I was so focused on the work that I didn't thought correctly. Fortunately, I was able to fix it and bring it to the vacuum station. So the first H-tube is finished and filled with gas. So let's connect it to the power supply. So the camera is running and the first glow of the H-tube. By the way, this is CD47, not that big. Oh, there is a short somewhere. Oops. Okay. So the anode is shorted to the digit that I want to use. So maybe... Okay, it's probably the topmost digit which is shorted to the anode grid. So I will just switch to other digit. Oh, yes. Number 1. It's shorting in the base. Wow, that's huge. Ah. I see the thermal wire is glowing. This is not good. This is not good. Oops. Number 6. This is not good at all. Oh. Okay, despite the fact that the digits were quite seriously oxidized during the sealing operation, the glow is quite uniform and the digits doesn't bend, they keep shape, which is important because when they glow they heat up and expand because it's metal, and in this case they keep the shape. This is great. This is great. So let's play with the other digits. The thermal wire is the first thing which is glowing. This is really disappointing. Maybe we will find a way how to deal with it. So this is the back of the Nixie tube, and this is the cerama wire which is connecting the digit to the stem, and it's glowing, like not much. You can see that there is a significant difference, but still it's glowing. Maybe it will go away once the tube is burned in, but I'm not sure. We need to try. But anyway, isn't it beautiful? It's really like this double contour is looking so cool. Number 0. So we have prototype number 2, and it's glowing, which is wonderful because it's just the second attempt to make a fully closed H-tube. There are some problems that will be necessary to solve. There are some issues that I didn't expect it, like the thermal wire glowing. I thought that it's a really good insulator, but maybe it will be. Maybe we just need to burn in the tube, and once the cathodes are clean, the thermal wire will not glow because the current will be lower. Anyway, we will find out in the next attempts. For now, I'm really happy that I was able to make such a nice seal, because I'm sure that having this tube I will be able to reproduce the result, and yeah, we will see. So see you at the next attempts at the prototype number 3, or maybe even higher numbers. So thank you, have a great day.